Hi student, this is Sivakumar. 11th standard mathematics, chapter number 7, exercise 7.3. Here, application of factor theorem to determinants. Factor theorem, the statement here it is, if each element of a matrix A is a polynomial in X and if determinant of A vanishes for X equals A. That means in the determinant, if we replace X by A and the determinant value is equal to 0, that is the meaning of vanishes, then we can say X minus A is a factor of determinant of A. This plus A comes left hand side, minus A. X minus A is a factor of determinant of A. Then these are the properties, the important properties to be learnt. Subdivision number 2. If we substitute B for A in the determinant, that is determinant of A, and two of its rows or two of its columns become identical, then determinant of A that is equal to 0. You know very well, if two columns or two rows are identical, the value of the determinant is 0. And hence by factor theorem, since we have replaced B for A minus B is a factor of determinant of A. Next one, if all rows or all columns are identical in a determinant of order n is greater than or equal to R, when we put X that is equal to A, according to the factor theorem, X minus A power R minus 1 is a factor of determinant of A. Plus A comes left hand side, minus A. Here all rows are identical, mean what should be in the power? R minus 1. If 3 rows are identical, 3 minus 1, that is 2 in the power. Is a factor of determinant of A. Next, so very important one, in the last subdivision, if the determinant is in cyclic matrix form and if M is the difference between the degree of the product of the factors obtained by substitution and the degree of the product of the leading diagonal elements, and if M is 0, then the required factor is a constant K. Then the second one is M is 1, then the required factor is K into A plus B plus C, and M is 2, then the required factor is K into A square plus B square plus C square plus L into AB plus BC plus CA. Okay. These are the properties. While working on the problems, you can easily understand what has been given here. Now we can get into that exercise 7.3, problem number 1. Look at that. Solve the following problems, each and every problem to be solved using the factor theorem. First one, show that determinant of XAA, AXA, AAX that is equal to X minus A whole square into X plus 2A. Here, this determinant is a cyclic symmetric. Why it is called a cyclic symmetric? No. Here we have only two variables, X and A in this determinant. In the first row, first element is X, others and all A. Second row, second element is X, others and all A. And third row, third element is X, others and all A. This is one cyclic order, therefore it is called a cyclic symmetric. Okay. So look at the factors of the determinant. We have X minus A, again X minus A because we have whole square, X minus A into X minus A into X plus 2A. So how to prove this result using factor theorem? Listen. Here is problem number 1. Using factor theorem, we have to prove this result. I consider the left hand side determinant as determinant of A. Let determinant of A, that is equal to x a x a x. Look at the factor x minus a the whole square into x plus 2a, particularly which is inside the bracket we have x minus a. Consider as 0. In a rougher column, take x minus a that is equal to 0, which implies x that is equal to a. Minus a comes right hand side, plus a. Let it be number 1. Put x that is equal to a. Here x equals a. Put x equals a in equation number 1. Therefore, equation 1 implies determinant of a that is equal to, have to replace x by a here. We will be getting a x that is equal to a right as it is. This x should be replaced by a. So look at that. We have a determinant. All the elements are a only. Here you write 0 because you know that in a determinant, if any two rows or any two columns, at least any two rows or any two columns identical, then the value of the determinant is 0. Here we have 3 rows are identical. You just write the reason. Even you can say 3 columns are identical. Write any one of them. I write here R1 is identical to R2 is identical to R3. So what is the determinant value? 0. That means the determinant A is vanishing. Determinant A vanishes. If it is 0, we can say vanishes. Therefore, what we have replaced here for x, a. Now, plus a comes left hand side minus a, x minus a power. At the same time, we have 3 rows are identical. If all rows are identical, according to factor theorem, power r minus 1 is a factor. Here, how many rows identical? 3. So, 3 minus 1 that is equal to x minus a whole square is a factor of determinant of a by factor theorem. Okay, now what is the next factor in the right hand side? X plus 2a. Consider as 0. Okay, take x plus 2a that is equal to 0, which implies x that is equal to minus 2a. Now we can replace x by minus 2a in equation number 1. Put x that is equal to minus 2a. Put x that is equal to minus 2a in equation number 1. Therefore, 1 implies determinant of a that is equal to, look at that, x can be replaced by minus 2a. Minus 2a, a. Again I tell you, minus 2a, a minus 2a, a minus 2a. Just you have to replace x by minus 2a. Minus 2a, a minus 2a, a minus 2a. That is equal to, here, is there any chance of vanishing determinant a? That means, is there any chance of getting the determinant value as 0? If you expand the determinant, instead of expanding directly, we can go for that transformation. I am going to change C1 or R1. I am changing R1. So R1 implies R1 plus R2 plus R3. I am changing that R1 only. So no change of R2 and R3. Write R2 and R3 as it is. A minus 2A, A minus 2A. So what I have written here, I am adding R1, R2, R3, that to be written in R1. This is R1, R2, R3. Add in this direction. That is A plus A 2A minus 2A 0. A plus A 2A minus 2A 0. A plus A 2A minus 2A 0. That is equal to, we know that in a determinant, particularly in determinant, if any one of the rows or any one of the columns, all the elements are 0, the determinant value is 0. Look at the determinant here. In particular in first row, all the elements are 0. So you can directly write 0 by expanding along R1. Suppose here if I put plus minus plus, you know that 0 into anything 0, 0 into anything 0, 0 into anything 0. Obviously, we'll be getting 0 at the last. So you can directly write. Okay. Now determinant of A vanishes. That means a determinant of A is equal to 0 by substituting x, that is equal to minus 2A. Now minus 2A comes left hand side plus 2A. So x plus 2A is a factor. Therefore x plus 2A is a factor of determinant of A. The next step, you have to write a degree of determinant of A and degree of the product of the factors of determinant of A. Okay. How to find the degree of determinant of A? In determinant of A, you just add the powers of the diagonal elements, main diagonal elements. Here x power 1, x power 1, x power 1. What is in the power? 1, 1, 1. If you add the powers, that is a degree of determinant of A. So 1 plus 1 plus 1, that is equal to 3. That is 3. Now degree of the product of the factors of determinant of A. We have the factors. Here is the first factor, x minus A the whole square. Okay. Here power 2. Now here another factor, x plus 2A whole power 1. That 2, here 1, add the powers to plus 1, that is also 3. So what about the difference between these two? Difference means you have to subtract these two. 3 minus 3, that is equal to 0. Since the difference is 0, what is given here? M is 0. M is the difference between the degree of determinant of A and the degree of the product of factors of determinant of A. That is 0. If it is 0, the other factor is a constant factor, that is k. I write here, since m that is equal to 0, the other constant factor is k. Therefore, determinant of A that is equal to, what is here? XAA, AXA, AAX, x a x, sorry, x, sorry, this is x, this is a, sorry, x x, okay, that is equal to, okay, listen carefully. First we got the factor, that is x minus a the whole square. First one, x minus a the whole square. Next we got that one, x plus 2a, here it is, into x plus 2a. Finally we got the constant factor, what it is, k, into k. Okay, let it be number 2. How to find the value of k? To find k, that is a heading. Listen, you can give any value for x and a, because we have two variables, x and a. Any values can be given for x and a, the condition none of the sides as 0. Suppose I replace x as 1, a as 1, you will be getting 1 minus 1, 0, 0 square is 0, 0 into anything 0, and 0 into k, 0. No chance of getting the value of k. So that any value can be given, condition none of the sides equal 0. For that, I am replacing x by 1 and a by 0. Okay, put x that is equal to 1 and a that is equal to 0 in equation number 2. Now replace equation number 2 in equation number 2. I am going to replace x by 1. We replace x by 1, 1, a as 0. A particular variable can be 0, but the value, determinant value cannot be 0. Remember, okay, should not be 0 actually. A that is 0, 0, and a that is 0, x that is 1, a that is 0, x that is 0, 0, 1, 0, 0, 1. Left hand side is completed. Now k write as it is in equation number 2, k bracket square bracket x minus a, x value is 1, a value is 0, x value is 1 plus 2 into 0. Now we have to simplify to find the value of k. Now I am going to expand this determinant by row 1 or 1, so that at the top of the first row put plus minus plus. Write 1 into, next one is minus 0 into anything 0 only, just put 0 only, next one also 0. First write 1, the element which presents the column and row should be eliminated. We have these 4 elements. You multiply the main diagonal first, 1 into 1, 1, then 0 into 0, 0, 1 minus 0. Right hand side k into 1 minus 0, that is 1, 1 square is 1. 2 into 0, 0, 0 plus 1 is 1, which implies here 1 minus 0, that is 1, 1 into 1, 1. So 1, here and all 0 only, write 1 only. Here k into 1 into 1, that is k. K that is equal to 1. I got the value of k. Now I am going to replace the value of k in equation number 2. That will be the final result. Therefore, equation number 2 implies, so write the determinant, that is a determinant of a. You write that x x x that is equal to, what is the value of k? K that is equal to 1, correct? If we replace 1 over here, 1 into x minus a the whole square into x plus 2a, 1 into x minus a the whole square into x plus 2a. that is equal to, here 1 into anything is same thing, so you'll be getting x minus a the whole square into x plus 2a. So what is in the left hand side? X a x a x. We have proved. Look at the question. Show that using factor theorem we have proved this result. Here it is. So by using factor theorem we have proved this result. So problem number 1 is completed. Then I'll be teaching problem number 2 in the next video. Thank you, children.